Today we are going to be talking about lesson 2B, multiplying expressions containing exponents. Mine is going to start on page 16. But before we get there, I want to remind you of our tool that we made last class where we created our circle that allows us to take a look at the different rules. Today we're going to talk about the power rule. That is where anything that is raised to a power gets multiplied together. We are going to talk about the power of a product rule, which is where you have two items that are multiplied together. Both items get the exponent. And our last rule we're going to talk about is our product rule today. And that's when you have the same bases multiplied together, you actually add the exponents. The difference between the product rule and the power rule is that this would have a single base and the product rule would have two bases where the exponents get added versus being multiplied. Let's take a look at a few examples. So I just explained our vocabulary. Again, the product rule states that you have one base and you have an exponent that's being raised to the power of another exponent, and so you multiply those exponents together. Whereas the product rule states that you are multiplying bases with different exponents, so you add them together. And then our last rule was the power of a product, which is where you have two bases that are different, you're multiplying them together with one exponent on the outside, and so it's like the distributive property where each base gets the single exponent. All right, so let's take a look at a few examples here. Our first example is just using the power rule. So this is where I'm going to take the exponent that is on the outside and I'm going to multiply it times the exponent on the inside. So this is going to look like x to the 2 times 5, which is equal to x to the 10th power. Our next example is similar, but this time around I am combining the power rule along with the power of a product. So not only will I multiply the 2 and the 3, but I'm also going to give the 3 to the c as well. So this becomes c to the 3rd power, d to the 2 times 3, which then simplifies to c cubed, or c to the 3rd power, d to the 6th power. Our third example is where we are using the product rule. So notice that I have the same base with different exponents. So because my bases are the same, I have 6 plus 4, which is equal to b to the 10th power. You may have seen something like that before. So this is basically saying that I have b times b times b times b times b times b. That's my b to the 6th. And then my b to the 4th would be b times b times b times b. Altogether, I have 10 b's, which is why we add. It's much shorter than having to write them all out. Our fourth example today is where we now have coefficients. So I'm going to take any coefficient that exists. Remember, that's the number in front of the variable, and I'm going to multiply them together. So this is 3 times 5, and then a to the 4 plus 3. So I really have 15a to the 7th power. Our fifth example takes it up a notch. Remember that I can write multiplication using the dot product or I can use parentheses to represent multiplication. When you see it written in parentheses, you want to, again, remember any coefficient needs to come out, so this negative and the 4 get separated. Then we write x times x squared, y cubed times y, and it's all being multiplied together. I do this so that I can see what's alike, so I know how to add the exponents. So this is negative 4 x to the 1 plus 2. There's a 1 on this x. And then we have y to the 3rd plus 1. So altogether, we have negative 4 x cubed y to the 4th for that one. And then our last example today, I'm kind of putting everything together. There's a power rule, there's a product of a power, and then there is a product rule. So let's first do the utmost, which is the power rule. So this exponent here has to go inside to everything, only that it's with. So the negative 3, the 2x to the 4th, it's not affected by this square that's over here. I have 4 squared, x to the 5 times 2, and then y squared. So I have negative 3 times 2x to the 4th. 4 times 4 is 16. We have x to the 10 and y squared. And now what we're going to do is we're going to bring out all of our coefficients. So negative 3 times 2 times 16. We have x to the 4th, x to the 10, and y squared. And I write it that way again so that I can see all of my variables that are alike. So I'm going to multiply the 2 times the 3 times the 16, and since there's one negative, I have a negative 96. We have x to the 4 plus 10 and y squared, and our last step is to combine those, so we have negative 96 x to the 14 y squared when we're all done. Again, remember, we are utilizing the power rule, the product rule, and the power of a product rule, and you can always turn back to page 14 and reference our circle at any time.